Hello, welcome back to Blender Sushi LiveNoding. In this episode, I'm gonna talk about voxel, 3D voxel. Basically, I'm always a big fan of pixel art and also the voxel art. And this is an app called Magica Voxel. I have mentioned it in the past a couple of times. And the other day, I actually look at some Python module that's dealing with Magica Voxel. Basically, I look at this one, PyVox IO by Gromgirl, and there's another one, VoxBox by David Williams. Um, they're like a tools written in Python, and um, basically you can kind of use this script inside Blender to generate some voxel, procedural voxel kind of art or mesh that you can open in Magica Voxel. So this it's going to be really interesting. I probably I'm going to make a couple of video talking about it because we can apparently learn a little bit about NumPy array, yeah, like a 2D and 3D array, kind of um, like a list of values that you can set up using Sverchok add-on or animation nodes, and then you can kind of translate all this value into something into a Vox file, which is for Magica Voxel. So it's gonna be quite interesting. I definitely kind of let you know, like you can try this yourself. Like a Magica Voxel is very cool little tool that you can really use to make like a voxel art, and you can just like test it out yourself. It's actually a very cool tool. I'm still learning. It's pretty intuitive in its own way, but and you can really just doodle around with voxel inside Magica Voxel. It's really fast, and the app itself is a very lightweight. You can manually kind of do this kind of thing and make like a random voxel art and then export it out to Sketchfab or Unity, Unreal, like making like a game assets. Um, but anyhow, I'm gonna talk about this guy right here. This is the setup that I already did. I'm not gonna start from here. I'm gonna start from scratch actually. And basically the setup that I have at the moment is I already installed this PyVox IO, and if I show it to you how it looks like, whenever you download Blender, and I'm using Mac, and inside the Blender package you can actually go inside, like select Blender and then right click show package contents, and then inside here you can dig down and then find there's a Python library. Let me try to find it. This guy right here, site packages. So you can see here, resources, and then go, you dig in until you find the site packages. And inside here, I already have the VoxBox and also the PyVox. Those are the two modules I'm using. Currently, just a PyVox is enough. And there is also the pill or image module. NumPy is something that's comes with Blender. PyVox is what's important. You probably need to have image module somewhere like a pill, but don't worry about that. I'm gonna let you know if we ever gonna need the pill or the pillow module. So you download it and then you put it inside Blender, and now we can use this module, Python module, to generate something like this. Not this complex, just a simple one first. There is actually a couple of examples given, but the example itself is a bit complex. I'll just gonna use this one, the first one. It seems like a pretty simple, only how many lines? Under 10 lines, and then there is this one line that's using the NumPy basically to generate something. What is something? We're gonna see real quick. I'm gonna save this. So it's gonna be a demo of PyVox. and I'm gonna create a text editor, new, paste it here, and let me try to make the text bigger so you can see it. There you go. I'll explain one by every line, but basically, if I try this, let's call this like demo 1 dot fox. So this is gonna be the output, right? Basically, it's gonna import the NumPy module with it, which is already built in with the recent Blender, and then it's gonna import these two functions or class from PyVox. That's pretty simple. The next line is the one that's kind of a little bit scary. What is this actually is a little bit complicated to explain, but I'll show you what I discovered yesterday. Basically, this line generates some kind of NumPy array, 3-dimensional NumPy array. We can't see it. This is like a single liner doing some crazy stuff. There's basically what it does is get all the points that's smaller than 4 units, I think, and then give it a true value, something like that. And the next line, it's gonna convert it into vox from the density, and then from here it's gonna write it out, demo.vox, and then let's try run it, and no error message, and seems to be doing something. So no error message. I can run it a couple of times, doesn't matter. I can actually print like success. Run skip a couple of times. It's gonna override it. So success. What's gonna happen is if I go to my user directory, there should be a new vox file, which is this one right here. Let me arrange it. So demo1.vox. Let's take a look. What is this? If we just drop it inside a Magica Voxel, now you can see it's just like a sphere, like a spherical 3D voxel. It's very cool, right? A single line can actually generate this. How is that possible? And we can try also like make a bigger number, like 6, and then run the script again. Let's see what it looks like now. Paste it, drop it here. We have, seems like a little bit bigger. Okay, cool. Let me try if I change the number. Oops, maybe 5 by 5. Maybe make this like 15, 15, and 15, and then run the script. No error. Just drop it. Oh, sometimes it doesn't drop. Okay, slightly bigger. So that's cool. You can now like do something here. Maybe like okay, there's a lot of tool here. Pattern, voxel, face mode. So that's actually pretty cool, and you can colorize it as well. A lot of cool things you can do in Magica Voxel, and they're all pretty intuitive, and you can change the palette very easily. This is like a nicer color. But anyhow, how is this possible, right? How we can simply create those simply by using this, a simple script. Of course, the script itself, to understand the NumPy array, it's gonna take you have to try it yourself, like what is this exactly. But I want to show you, if you actually like print this out, print a, which is this is variable, the variable that contains this information, and then being converted into vox using like a parsing of this this module PyVox. But what is actually a? A is a NumPy array. What's NumPy array looks like? Let's print this out. Run script and take a look. So this is how it looks like. This is the NumPy array. So this is the success. This is the last line. But this is the NumPy array. Look at this. If you look at this and then compare it with this result, you can already see this is the actual 3D voxel data layer by layer, right? This is what interests me to actually explore this a little bit more, because this can actually help you to understand a 3D vector array. And actually Sverchok can also produce this kind of data like on the fly. And you can see by these 3 brackets right here, 1, 2, 3 at the bottom, and then the second one is like a 2D array. This is representing one single layer slice of this 3D voxel. And then the next one you can see, okay, true, 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 true. So there are 4 true, which means 4, this 4 string at the top, and then it goes to the next one and go to the next one, oops, which is this guy right here. Well, anyway, you get a point. And then it's continue on, and then this is the largest one, and then it gets smaller again. So this make up a 3D voxel. If you want to investigate, if you want to generate this inside Blender using Sverchok add-on, you can actually do that somehow easier than actually to type it with code. I'll show you a simple one. Let's try with a 2D array. First of all, 2D array. So let's say instead of using this NumPy array and print it out, let me comment it out. I'm gonna change this with something else. Maybe type my own so NumPy array, if I'm not wrong, if I'm doing this correctly. Maybe not NumPy like that. Maybe np.array. And we're gonna type it like this. Let's try make a 2D array first of all. 2D or 3D, I'm not quite sure. I think I need to make it 3D. So 3 bracket to enclose our information about our true or false. So let's try this. So 1 0 1 0 1, and then I'll make a couple. So three layers, and this is gonna be like a single I think 3 voxel, 3 layers of voxel. I might do it wrong, but let me try. If I run it and I get wrong, then okay, I'm getting an error. So it's gonna tell me what's the error actually. The axis entry is out of bounds. Okay, what's that supposed to mean? Maybe I have too many brackets. Let me try again. Run the script. This time actually it works. NumPy array. So this is bracket, and then so 1 2 3. 3 layers. It's gonna be a single layer, I believe. So let's take a look at the result. Drop it. Okay, so it's starting to make sense. So 1 2 3 and 5 across. So it's 3 by 5, and we have true, false, and true, false, and true. Right? You get it? So 1 2 3 4 5. This is a 2-dimensional array, 5 by 3, because we have 3 lines and then 5 here. So that's kind of makes sense. Let me try again. This time I'll have like a variable called b. This one I'll change it to b, and I'll make this like 1 1 1, maybe a 0 in the middle. This should be 1 and 1 and 1. So this is like a true or false. If I run the script, this is gonna generate a vox based on this data. Drop it here. So we have 1 1 0 1 1. Okay, so that makes sense. If I invert this guy, so 1 becomes 0. So that's typing it by hand. Later on, we're gonna learn how to create this using Sverchok. I think it's really super interesting. It's how you can visualize code. You see, this is basically this data. Whatever is 1 or true, it's gonna generate the voxel. So that's cool. I can actually continue on with this. If I want to have like a 2-layer, I believe I just copy the middle part and then make a comma here and then paste it. This is gonna be the second layer, believe it or not. Run the script. Oh, it's giving me an error. Okay. Apparently I need to have another bracket now because it's now it's becoming a 3D array. So keep that in mind. This is still giving me an error. What's the error message? Out of bounds. Okay. Maybe I shouldn't go 2D array. Like I shouldn't go 3D array for now. Keep it simple. We're gonna save 3D array for the next one. So let's generate something with Sverchok first. That's the idea. Okay, with Sverchok, let's say random value true or false. We can generate using random number, basically. Right, random number. By default, it's gonna generate this value 503379. It's basically a random number between 0 and 10. 10 of them. Since we just need a 0 and 1, true or false, I'm gonna replace it integer 0 low for low and then 1 for high. So I get this value 0 and 1. Yeah, this is the result 0, 1, 1. So this can be something that we can paste into Vox, right? We are already starting to get something, and to make it clearer, I'll create a new text, and I'll call this SV out, and I'm gonna use text out here, and I'm gonna dump this value into this guy, dump it. So this is what I get by default. We want it to be Sverchok and then compact or pretty, make it pretty, and if we dump it, we have this value, and I'm gonna make this larger as well. So you started to see this is how data being stored inside Sverchok. Whenever I talk about Sverchok and like a level of data and then how it's wrapping all this value, this is how it looks like. And you can use this to create Vox based on this pattern. You know, we're gonna try to create something like this. Let's see what we actually need to do. If I'm not wrong, if I just copy this and then let's try and do it like this, np array inside the bracket and then paste the Sverchok one and then replace this with C and then run the script. It's gonna give an error. Wow, what's going on? I expect a 4 or 3-dimensional matrix. All right, maybe we need to join it. So list join, dump it again and nothing, wrap it. So I'm wrapping this random number data into this guy right here. So copy and paste. Now see three brackets and then all this data in the middle. So that seems correct. Run the script. Now this is actually working. Drop the Vox into this guy. Now we can see this is like 0, 1, 1, 0, 1, 1, 1, 1. So you can see 0, 1, 1, and then 0, 1, 1, 1, 1. Okay, that's like 10 random value. This is like a single dimensional array, if I'm not wrong. It's only a single line. Let's say I want to have a multiple of this. How do we do that? There are many ways. This is one way you can clearly see. So I'm duplicating the random number. I'm gonna randomize the seed. So each one is gonna generate a different random 1 and 0. Plug this into this guy. Now we should, if you dump it, we should have three value that we can paste into this guy, this NumPy array. NumPy array will be converted into Vox. Run the script, and we should see a new result. So 0, 0, 1, 1. So let's check it out. 0, 0, 1, 1, 0, 0, 1. See, it seems like upside down. Let me check. So 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, and then 1, 1, 0, 1, 0. So yeah, this is correct. And if we want to be like really precise, look at this axis. Inside of Vox, the X is running this way and the Y is running this way. So that's gonna match this pattern. So that's really cool. Yeah, so that's actually the idea. You can continue like generating the random value here. You can do it in many different ways. If I'm not wrong, because Sverchok handles like a multiple slicing and vectorization, you can actually like create a range integer here. For example, I make like a five range of integer and plug it into the seed, and this should practically, I think it should generate a proper value for us. Let me check, dump it. Maybe I need to join it as well. So yeah, this actually will generate 1, 2, 3, 5, 10 by 5 2D array. Run the script. Oops, it says an error because I'm missing a bracket. Invalid syntax. Invalid syntax. Maybe I did something wrong. Copy, paste. Oh, I'm missing a bracket, right? Run the script. Okay, I accidentally delete a bracket. So run the script and then look at it. Look at the result now. It's a 2D array with a random value. So 10 by 5, random, and then you can give it a color, you know. It's very interesting how this can work, and you can render it out. I really like the voxel renderer here in Magica Voxel. It gives you a really nice, like very easily, like nice result. You can change the lightning and also with the color. So let's say this the pink color, I just turn it into emissions. This one is gonna be like glowing. It's very cool, really very cool. And you can get a nice result very easily for voxel, of course. Let's go back. So what if now I want to go a little bit crazy and make like a 25 by 25 by 25, and this one's gonna be 25 as well. So dump it. Wow, this is gonna be like a long list. Maybe I even make it more like 50. Dump it. Very long list. I can, from pretty, like now we can see this pretty line. We can turn it into compact, and then just simply turn it into a single line that you can dump here. Now if I run the script and look at the result, it's gonna be like that. That's amazing, right? So this is procedurally like this is a 2D voxel, generally procedurally generated using nodes, Sverchok nodes. And yeah, this is like a 2 example, the most basic that I could give, and definitely you can try it yourself. And then using all this all the nodes inside Sverchok, you can generate a pattern that's gonna work inside Magica Voxel. So that's the idea basically. Of course, don't forget one more thing, that from this data you can also, of course, generate it inside Blender. You can have this inside Blender. Using this value, you can convert it into a box in Blender very easily using list masking. I'll show you how we can do that in the next live noding. I think this is like a lot of information already. Remember, this is like 0 and 1, and it's an array, 2D array of Boolean value true and false. You can use this as a list masking, basically. List mask. And with this list mask, you plug the mask there, and the data can be a vector. If I'm not wrong, this is gonna work. And make sure the dimension is correct. You plug the point data there, and then you can generate like a bunch of box that's basically matching this guy right here. 2D is much easier. Next one I'll talk about 3D array. This is 2D array, very basic, but still it takes time to understand this. Once you understand this, you can do furthermore. So far with the PyVox, to do the coloring procedurally, I'm still have to think. I have to dig inside the code. Voxbox seems to be doing it, but also the example here is so complicated. You can create something cool with a Voxbox. With a PyVox, the example is a little bit simpler, but you use a lot of NumPy. Also, so far I only understand the generate one. This one makes a bit of sense, but anyhow, the main point is to understand the NumPy array, 2D NumPy array that you generate using Sverchok, and then you pass it here and generate a Vox, like this kind of data, and you can color it. This is very interesting and very relaxing. If you're coloring a voxel, is very like fun. But anyhow, that's pretty much it. Hopefully you enjoy this. Let me know what you think, and I'll see you next time. Thank you. Bye.